We got enough seats for everybody. Plenty of seats. There's always seats up at the front as well. Nobody here bites. In, come in. If you haven't got a drink, you've got about 10 seconds to grab a drink as well. Yeah. Wow. I love how the room just goes silent quite easily. Everybody's really keen to hear our talks and to learn, and obviously really keen to hear me talk nonsense for 5 minutes and welcome you and introduce you to the Brighton Data Intelligence Network. If you've come here expecting Brighton R or Brighton Pi or the Sussex Data Science Meetup, this is the same thing. This is all three of them merged into one bumper, super, mega meetup. And so it's great to see people from all ends of the coding line here. We've got R, we've got Pi, we've got people in between. If you're not sure, this is an R meetup, obviously. R is king. R is more king than Pi. Can we get a cheer? It's better than I thought, actually. I thought there would be a lot of Python people in the room. Excellent. I'm just here to do a little bit of the housekeeping and to introduce our wonderful speaker for this evening. So I'm Jeremy. I'm the founder of Data Cove. I'll tell you a little bit about what we do in a second. You'll notice there's Laura's face on the slides as well. Laura was meant to be here introducing this and going through the wonderful bits of housekeeping with you. Unfortunately, she's not well this evening. So you are stuck. Oh, there we go. Can we do a bit louder in case she's watching? There. So you're stuck with me. I know, exactly. God help us, more like. So Data Cove is my business, founded 5.5 years ago. I'll tell you a little bit more about that in a second. A couple of bits of housekeeping. We love our social media. I'm going to give you a little hashtag to use in a second. So we will be snapping pictures throughout the evening. If you do not want your face to appear all over our social media, or possibly on a banner, if you've seen our new beautiful Earl banner, at the back of the room, please come and let me know at some point this evening. Let me know if you're Python, I shall put a snake over your face. If you are, tell me your favourite package, put that hex over your face and you won't appear. We also have a wonderful and lovely speaker this evening, Craig. Craig is lovely. Craig does not like to be heckled. I don't like, you probably will. I don't mind being heckled either. Craig does not like being heckled, however. He does like kicking my drink over. Luckily, it wasn't open. Craig does not like being heckled. So please, if you have any questions, wait for the end, put your hand up, and we will come round with a microphone. I said we're very social. Do share your experience of this evening. Put a social post out. Show us some love. And use this wonderful hashtag DataCove Network. We will respond, we will share it, we will make sure that it gets the love that it deserves as well. So post your favourite pictures of this evening on socials. I said we've got Craig speaking this evening. The talk is going to come in 2 parts. So there's excellent news because halfway through you'll be able to go and refresh your drink at the back of the room as well. So we're going to have a 2-part talk from Craig, a break in the middle, a few minutes of me at the start, unfortunately, and a few minutes of me at the end. But I'll try and keep that as brief as possible. I'm going to tell you a little bit about Data Cove though. So we are Brighton-based R, Python and Shiny experts. We specialise in 3 core areas. So we've got consumer and marketing analytics. So this is helping you bring more people through the door by spending less money. Who are your best customers? How do you find more of them? And how do you do it by spending less? It is possible. If you think it is not possible, come and chat to me. Or even buy me a drink in the pub later on. Not that I'm scouting for free drinks or anything like that, but come and buy me a drink in the pub later, and I shall tell you how. Data visualization and web applications, so it's building tools that allow you to make faster decisions, bringing all of your data into one place so that you don't have to open 50 of those horrible spreadsheets to make one decision at work. It takes you 5 days to do, so we bring all of that into one place. We build apps for the government and all sorts of other people as well. I'm sure they need a lot of help at the moment, but we won't talk too much about that. And we also do a lot of community stuff, which is why we're all here tonight. Data Cove Network, Data Intelligence Network. We run a fantastic conference. If you've seen the wonderfully, so new that banner, it smells new. It's going to smell of pizza very soon, but it smells new for tonight. You've seen the banner at the back, and I'll tell you a little bit more about Earl in a second too. We do training, so you might have seen a couple of little boards up of some of the training offerings that we have. And we also have a Your Data Team service. So if you want somebody, or if you want a data team, but you're not an organisation that's big enough to need to staff out your own data team, we can do that for you, so we can be your data team effectively with your branding, or you can call us as external people. And then if you ever want to hire in your own data team, we run these events everywhere. We know the best data people in the country. We can help you find them as well. And talking of running the events everywhere, our data intelligence network, it spans 6 wonderful cities. You're in Brighton at the moment, but we are also in Bristol, Birmingham, Manchester, London and Portsmouth. I think that's all of them. I always worry that I've missed one out. Our next and upcoming events in all of the cities, you'll notice we're going from Bristol to Manchester on adjoining days. Don't know how we quite managed to plan that. And then we're in London and back here in Brighton towards the end of July as well. But we also run a fantastic conference, as I made mention of our beautiful, sweet, non-pizza smelling banner at the back. We run EARL. EARL did stand for the Enterprise Application of the R and Python Language Conference. That's a mouthful. It is a global data intelligence event. So it brings together people from all corners of the world, maybe even all corners of Earth, probably, because some people that work in data are very eccentric, as you can imagine. Don't know who I'm talking about there. But it brings together people from all corners of the world to chat all things data intelligence for 3 days in Brighton. We got a day of expert-led workshops, we got fantastic keynote talks, and we got industry-led talks as well, including some from local professionals. There may be EARL royalty in this room tonight. There may be a speaker among us. We've got to find who that speaker is by networking really well, because the agenda has not been released yet. But it takes place over 3 days in October, over 200 people, 50 plus speakers, we say. We haven't quite counted them up yet, but there's a lot of different speakers from a lot of different industries, lots of opportunities to learn. I'm really excited this year that, well, the agenda should be being released in the next few days, but so far we've confirmed 2 excellent keynotes. We've got Nicola Rennie. Nicola is, if you haven't seen any of her social media stuff, constantly blogging and talking about data visualization. She's a massive champion for making sure that you visualize and use data in a way that's easy for other people to understand. She's written books. She's part of the Royal Statistical Society's board. She's got a fantastic, fantastic CV. She's going to be on the stage sharing some of her insights with us at EARL. And recently announced, you might not have seen this was only announced last week, we've got Leanne. Leanne is Director of Data Science and AI at the Financial Times. So she's joining our keynote lineup as well. One more keynote to come very, very shortly as well. Some of the talks, I say the agenda hasn't actually been released yet, but you will see some of these companies, hopefully, if they all say yes. No, they've all applied. Some of them are on the naughty list. We're not filling out their speaker forms yet. We won't talk about who they are. But these are some of the companies you'll see. It's going to be a fantastic 3 days. We've also got brilliant networking opportunities new for this year. On the workshop day, you do not have to be a workshop attendee to come. We've got a wonderful networking lunch, very, very reasonably priced as well, if I do say so myself, £39 for a lunch. That's on the workshop day, so the Tuesday. Come and have lunch with our wonderful workshop delegates and other data science or data intelligence professionals. And then we've got the epic evening event, which is going to be here. It's going to be on the pier. It's going to be in Palm Court at the back of the pier, beautiful venue inside. We're going to have pier level entertainment. You get to go on the rides after dark as well. Food, drink. It's going to be a proper Brighton experience, and networking with coding professionals too. Tickets at the moment are at the early bird rate, but not for much longer. Only for another couple of weeks. So there is a beautiful QR code here, and there's a few more around the room on that banner. So do scan the QR code, have a look, go back to your boss tomorrow and say, you need to pay for me to come to this event. It is the best data intelligence event in the world. I must be there. So please go away, tell your friends, tell your boss, sign up, come and join us in October. It's going to be a brilliant 3 days of learning and inspiration all around data intelligence. You will be very pleased to also hear that this is nearly me done. I will be sitting down in a minute to enjoy my beverage. But before I do that, I would like to say thank you to our wonderful hosts for this evening. This event just would not be possible if it wasn't for the kindness of Platform 9 to give us the venue, for the Eagle Labs and all of their support, and to Silicon Brighton. So I am first going to welcome from Eagle Labs, and to talk about Platform 9 as well, the wonderful Andy.
anywhere will do. Hold it if you like.
Shall I just hold it? Hold it? Is that all right?
Yeah.
Okay, so welcome everyone. Welcome to Platform 9. If this is the first time that you've been here, Platform 9 is a co-working site. So if you are looking for co-working and you want somewhere to work that is vibrant, fun, the home of Eagle Labs, the home of data intelligence with Jeremy, come down. Oh, and Silicon Brighton as well. Yeah. We're all here. Yeah. Did you see that? I could feel that. Get in contact, speak to any of us, and we can sort out like a show round. And if you like it, come and join us. Part of a bit of health and safety bit that I need to talk to you about. So if the fire alarm does go off, we'll follow Jeremy because he'll be straight out the door, and literally it's through the doors where you came in, the lifts, and straight through the door at the end. If you need the toilets, they're both just through the red doors, ladies on the left and gents on the right. So Eagle Labs, what are we? So we are a business incubator. So we are here to help and support businesses to grow and scale. So if you are on that journey and you want some mentoring or you want to have an accelerator program, speak to me. We can put you in contact with the right person that will be able to help and support your business. We also love supporting Jeremy and the team here to be able to put on events, the networking events that we do. We've got an amazing platform online called Communities where you can register your business, and anyone within the Eagle Labs community across the country, we've got 43 sites across the country, can view your business and you can connect. So if that's something that you are interested in or want to know more about what we do and how we can support your business, speak to me. I will be here. But enjoy the evening. Thank you.
Have we got a clicker? You do have a clicker. Thank you very much. Cheers, thanks. Hey everyone, my name's Cameron and I work for Silicon Brighton. Yeah, Andy just gave me a funny look there. Good. And yeah, we are the hosts of the digital tech sector in Brighton and Hove. This is not me in this photo pictured at all. That's my friend Spencer, actually. But that's our founders, Grace and Steve, at our Evolve conference, which I'll get to in a moment. As I said, hosts of Brighton and Hove's tech sector, looking after loads of different meetup groups all across Brighton and Hove, where we've got our data-focused meetups, our web developments, our hardware meetups. So if you are interested in any other sort of meetup in the digital tech space, I would 100% check out those. We are also supported by loads of different businesses, including Data Cove and Eagle Labs and Platform with our new workspace. This is a great list of local businesses. If you want to get in touch with them to either offer your services or see if perhaps you need their services, 100% get involved, keep it local. That's what we're all about. A huge thank you to our supporters as well, our sponsors, sorry, who assist us even more, allowing us to do things like live streaming like we're doing tonight, as well as supporting us in our Evolve conference. This is going to be huge. We did it last year at the Brighton Dome. I think that's 1,000 capacity. We sold it out. They were trying to get in through the door. I think the Dome staff were panicking. They didn't want it. But it's the meetup of all meetups. So across the day, loads of tech, loads of data, all stuff that you'll be very interested in. And we do have some discounted tickets, which I'm very sorry, Jeremy. I have put Brighton Pie as it's a pie event, but these are going to be half-price tickets. It's a data intelligence, but I know he's running Python. I know that much. So yeah, we're still on the old codes. Sorry about that. But a bit of competition for Jeremy. Next event, I'll do Brighton R and see what the uptake is. So we are beyond our early bird prices now. We're at £40 a ticket, or I think it might be £12 for student. It's a half-price ticket. You might hear conference think a bit expensive, but we're really community-focused. We want to get everyone through the door. So yeah, please come along. This clicker won't work anymore because I've been silly. But that should be me. Oh no, there you go. Someone's actually done the proper code. So yeah, if you fancy supporting the Data Cove Content Network as well. That's me, Jeremy. That's me done, I think. Oh yeah, and you can stay up to date on all of our activity and more. We've got a Slack channel, which is brilliant for the community as well. I know Platform has a brilliant Slack channel as well. So taking a lot of lessons from them as well. And over to, are you going back, Jeremy?
You can introduce Craig.
I can introduce Craig. Yeah, you can introduce yourself. Yeah, brilliant. There you go. Cool.
thanks.
Good. There's a QR code for the GitHub repo that contains all the links that I refer to, everything. It branches out, so that's the only thing you'll need tonight, and everything that I use and more will be in that. Just before we start, I just did a quick look for like AI agents on YouTube, and you may have seen a lot of these AI agents build your own company, hire employees. It can seem quite mysterious as to what an AI agent is, and tonight we're going to really break it down so it actually seems a lot more simple and demystified. So we'll close that down. And actually, it was very kind of Jeremy to say not to heckle. What I'm going to do for this one is actually, let's make it more of a conversation, that as we're going along, if you've got questions or comments or thoughts, let's do it, because sometimes there's more value in what a person asks and homes in more accurately. So we'll have some questions at the end if people need it, but as we're going through, feel free to sort of pipe in, and we'll have a conversation about AI agents. And data intelligence, let me take that out of the way. Lovely. Good. Firstly, thank you all for coming tonight. Really great to see everyone here. What is the aim for tonight? I wonder if I can just make this a bit bigger. The aim is to see what an AI agent is at its most basic form. So when we see all these mysterious coding agents or frameworks about building an AI company, we can actually see what goes on behind the scene, but what gets expanded through the use of code and other techniques. We're going to look at the kind of core concepts of like memory, context, that's the information you send to it, looping, and tool calling. And when we do programming, you might say to a new student, if you know how to assign a value to a variable, if you know how to do if-else, and if you know how to do loops, that's really the core building blocks for any program. And in a sense, these are the kind of core building blocks for all the AI agents that you see, the coding, everything like that. They're built on these fundamental concepts. And what we're going to do, we're going to have a look at that. We're going to have a look how we can create them in basic HTML, just with what we call an API request, a bit like you're sending an email, sending a request somewhere, getting a response back, just to see how we can do it in its rawest form. Then, having seen some examples in HTML, what we will do in the second half is look, well, how can we expand on all of these to create like a mini coding agent or a personal agent for us, before leading into, well, how can we use all these things for data intelligence? How can we take like a Kaggle CSV and do many different things? So who am I? I'm just one of us. I kind of work in Python, agentic engineering, coding, working with Claude Code, Codex, etc. Like everyone else, just getting to grips with all these new technologies. I mean, I spend a lot of time studying, which is watching YouTube on my couch. And basically, it could be a full-time job just to keep up to date. And even then, I wouldn't keep up to date. And there's an old saying, it doesn't get any easier, just different. No matter how long we've been studying technology, it's always something new to learn. It's just different. I've been a sort of business information architect, SQL DB, an accountant at various points in my time. And there's a link to my website. My dogs that I've got a fox red Labrador, Leo, who's now nearly 2. I'd recently got a little cockapoo puppy, tiny little thing in the size of my hand. And that's them together. We also have red foxes where I live that kind of, they look at each other thinking, are we the same species? So yeah, he's always following us, that fox. And my first computer back in 7980 was a paper tape reader. And cut and paste was cut and paste. The first thing they taught you was how to join bits of tape together so it all worked. And I remember crashing a program by treading on the tape as it was going through really fast. So that's my first computer. So what is an AI agent? So many different definitions. I quite like the Anthropic version. Systems where the LLM, the agent, the model, decides where to go. And that's probably one of the key things, that when we kind of use agents, they can come up with a decision, take route A or route B. So in a sense, although we may create the overall structure, like in Brighton, the city of all the roads, how it gets from here to, say, Hove, is up to the AI agent. And that's the degree of autonomy, because it can think about. Now, what I'm going to say tonight is, I'm going to try and demystify and simplify everything. Don't worry about this code here, but this is actually what AI agents are. I've done many talks on AI agents. This bit, and this is really just sending a request, some information to a server, getting a response. This is agentic engineering, just this one slide. We're going to go deeper, and at the very end, you'll see how actually just knowing this, and we'll explain it later, is really fundamentally what an AI agent is. And I did this talk once, and somebody said, that's a bit underwhelming. And I actually found that that was a compliment, because actually it is something quite basic. It's just built up with lots of repetition of these building blocks. And as I say, this snippet of code is the most important takeaway tonight, and it'll be explained. But for those that know JavaScript, it's making an API request where we send information to a server and get a response, a question and answer. Same in every language. Maybe it has a slightly different syntax in terms of the programming language. But it's like sending an email. And we're going to be using email as an example to understand AI agents in a way that's non-coding. And one of the important things is harnessing. In the early days, it was prompt engineering. You'd kind of make a statement and the cat sat on and almost prompt the model to finish it. That was prompt engineering. Then it moved into context engineering, where what was really important was what information did you supply along with your question. If you're asking about sales performance for a company, you need to send some sales data. It was getting the right information along with your question, because the model probably wasn't trained on your information or your use case. And then finally, we've moved into what they call harness engineering, where it's taking this simple building block and how do we kind of manage many of those and put it all together? How do we make an application? So it's prompt engineering, context engineering, harness engineering, but at the end of the day, it's a question answer between us with a bit of code and with these foundation models. And what we get back, as mysterious and magical as it be, is what we then work with in a very traditional way. So that is my focus tonight. Demystify and simplify it. So when you see different things, you may have used Claude or Codex, or you've used ChatGPT, you can actually understand how it's working behind the scenes in a simpler way. And for me, once I understood that all of these AI tools was basically an API request, sending something, getting a response, going on. In the same way that if you've been doing data science, you might get pull and stock data or other information. You get it with a request and a response. Then you do something else in a very traditional coding way. So there's sometimes the AI part, just one small little bit. And when I've looked at various libraries, among all the big code, you'll just see one little statement like that snippet, fetch a response based on a question. Now, if we have a mouse and we turn it upside down and try and use it, it's going to feel very, very awkward. But it's nothing different to what we do day to day, up, down, left, right. And that's what this talk is going to be like. I'm probably going to say to you, don't try and understand this if you've not come across AI agents, because it's very different to the way we've been working, that we know everything that goes, we know every line, we know what we're doing. Here you're sending off a request, getting some response, some directions, and thinking, well, how did that give me that answer? So tonight, don't worry if it doesn't quite click. It took me a little while, a few examples of going through and thinking, yeah, and it still seems a bit bizarre and magical even now with all this AI stuff. But actually, it is very much looking at things from a totally different perspective from what we've trained. So just take this as a high-level overview. Don't beat yourself up if it doesn't click. I've done this type of talk or workshop 10 times now, and we're all capable people. Everyone looks and sort of like think it's some like magic trick or some sort of smoke and mirrors. So that's bearing that in mind. So let's use email as an example. We're very used to using email or Slack messages. What we're really doing with agents is sending it to one endpoint, always the same. It's not like when we do programming or applications where we send it to different points depending on what we want to do. It's always the one place, the one company. We send it, we ask a question, we get a response back. If we want to send a follow-up question, as we'll see, it won't remember what happened before. One of the most important things is, by default, it is stateless. So when we do like our ChatGPT and ask a question, ChatGPT knows what we said before because it's got an application behind it. But if you're doing the raw API as an agent, it has no memory. So if we say, what is the capital of England, it'll give us an answer. If we say, what's its population, don't know what we're referring to. And that statelessness is something just to bear in mind, because we see how we overcome that. What we can also do is add extra information. Because, for example, I use this example of Brighton Data Intelligence that was first in October the 29th, 1865, for example, to know that it wasn't in the training data that it was trained on. We can add extra information so that when we ask a question, it can refer to the information we sent with it. When we ask a question about sales performance, we need to send it sales data. That's the context. And it's sometimes called in-context learning, because basically you're giving it some extra information that it can answer your question. So if we were sending an email to somebody, it has no memory. This was the one about what's its population. We will then find actually that we would need to kind of send that information so it can answer the question. One of the other things, that was context. We've done history, that if we really want to kind of ask a follow-up question, as in any email, we need to look at the thread. So by default, you always have to send a brand new email. But what we'd like to do is to be able to have a history, a memory of what went on before, so it knows what it refers to. The other thing we might need to do is be able to supply extra information, the context, at runtime. We don't know in advance what it's going to do. And the example we're going to look at is if we ask, what is the temperature in London now? It needs to have a tool to know what the time is, what's the longitude and latitude of London, and get temperature for that longitude and latitude. So how do we supply those functions? There is a way that we can actually do that we can tell it, by the way, if you need any of these information, let me know, supply me the values, and I'll work it for you and send it back as a history, as a sort of list of messages. And if we look at the example that Anthropic gives us, we can see that we do the first request. It says, you know what, I need a particular tool. I need you to get the temperature right now. So we hear that response, and what we then do is we basically run it on our side, get the extra information, and then send it back again. So we're building that sort of email thread. And this is dynamic, and this is called tool calling or function calling. And it gives us great abilities, really, to do all these things, like all the things that you see in ChatGPT, these applications. It has lots of tools that it can call upon, like a web search, if you want it to do deep research. It's got a web search tool that can connect to the internet, get data, bring it back. That's run on our side. Then we send that back to, say, OpenAI to basically use that information. And then finally, we have the looping. And really, it's just going round and round until the model says, I've got enough information, I can give you a final answer. So it's called the react, reasoning and acting. It thinks, asks us to do something, goes round again. No, I need a new information. We saw we need to get the time now. It's got that, comes back, says, right, now that I've got that, I need the longitude and latitude of London. We supply it to it. I don't know, I need to know now, kind of get the weather data for it. So we supply that, send it to it, then it formulates a nice answer. And we'll see that in the HTML examples to make that easier. So it's history, list of messages, memory, tools and functions, and looping. And history and memory are sort of the same. There's a difference. It can be short term, it can be long term, and we'll see examples of that. So what I've done is very quickly covered these areas. And the most important thing to remember is that unlike normal connections to get data, we do everything on the client side, all the kind of what we want, and send it. We don't just send a request and there's information stored somewhere on the model that gives us the answer. We use natural language. We're going to see examples of that as we go through. And it's also autonomous. That's how you see these examples of long-running tasks that the agent comes back, sends and decides to do this, decides to do that. We give it the ability within our confines of the routes that we can actually have of how to get from here to Hove. And for the purpose of the talk, I use the term function more in the term of mathematical sense. We give it something, we send a request, the function does something and can also return something. It might store information in a database, it may send a response. We can then take the output of that function and pass it into another function call. And that's the idea of looping. The result of one request may be incomplete, we can then do another, or it takes a different path. And it's kind of explained sort of like that. And that's standard in all programming languages. And the key point is that when we're talking about these AI agents, most of it is traditional coding. It's just sometimes it needs the weather data. It needs a function call to the model to get a particular answer so it can proceed. So if we really think of these applications, these agents, as just traditional application, but making API requests to a large language model, getting a response, then doing something. So that's quite a lot of information to take in about what an AI agent is. How does that sit with people? Is there anything that's kind of I've not explained properly, or is there any thoughts about that? Because I find if I'm stuck on something, I can't pay attention to what goes on further if I've got something niggling in my mind. So are we sort of comfortable with that?
I'll just check one thing. So with the tooling part, is this the top? Yeah. Yeah, with the tooling part, is it always the case that there's an app layer that calls the tools, like the model never independently calls the tool itself?
What we do is we send, and we'll see an example of the code, we send along with our question, we'll say, here are some tools, this is what each tool does. If you need it, decide which one you want, let me know which tool you want me to run, and which kind of arguments we want to pass. We'll see that when we go through the code and the example. But essentially, it's kind of like that. It's a bit like if you're sending an email and you're asking questions to a colleague. They say, yeah, but can you first run this report and send me the data back? Because I need that to answer your question. Yeah, that's a good question. I mean, that's kind of... So we've seen history, looping, context, and tools. Now, let's quickly, just before we go into the examples, let's have a look at that bit of code here. A bit hard to see that. I just should be able to open the image. What I'm going to do is scroll down. Lovely. Let's go in here and let me... do that. Is that clear? Or is that good enough or a bit more? Right. So really, I talked about that snippet of code, and just to show what it is, we send it to one particular endpoint. We don't change it. We obviously have to send some tokens here so that we're authorized. And what we do is we tell it what model we want to use. We give it a list of messages. It's split between system and user. System is like the core that you don't want to repeat each time. The user is every time the user asks a question. It's like a function that needs two signatures. You've got to supply two arguments, otherwise it will crash. But they can both be null, or you can have one that contains both. But what we're basically saying is the system prompt defines how the AI should work. You're a skilled data analyst, yada, yada, yada. Then the role the user may ask the question. So we just send it a list of information and questions. We can have other parameters like how long the answer should be, a question on temperature, on what sort of degree of flexibility or creativity we can give it. We won't go into that because that's a bit of a rabbit hole, but there's a document in the repo that explains that. Now this is it. You're sending, like an email, to one email address. You're sending along what model you want. You're sending a list of your questions, that's the user. You're sending a list of maybe the information that you want analyzed, that's in the system prompt. And that's basically just a variable of information. And then you'll get an answer back. That, you can see, is something that we'll see expanded upon. So that's the example. So what I'm going to do now is actually go into and see some examples of... So the very first one, let's open this up. These are all in the repo, by the way. What is the capital of England? So we can send the request. It comes back with an answer. By default, if I say what is its popu and send it, I program it to say I don't know, rather than giving some complex answer. Simply because remember, it's got no memory. Every request is unique. Now what we'll do is actually look at what if we supply it with extra information. So for example, in this one here, I added that information about the very first meetup in 1865 and who it was organised back. I can ask a question, when was the first meetup held? It comes back with its in-context learning. The model wasn't trained on this information. I've purposely done something different. It comes back with an answer based on the information we supplied it. Remember I said it was the Brighton Data Intelligence, 1865. Now we come to the tool calling. I've got two functions, get the weather, that doesn't really take any arguments. It just, for the sake of the demo, just gives it. And something that adds two numbers. So I've got here is what is the weather in England. So first thing it does is it calls OpenAI. OpenAI responds with saying, can you give me the get weather? Can you run get weather for me and send me the data? So we get the result, which is this. We send it back to OpenAI so it can formulate its answer. And the answer it gives us back, the current weather in England is 25 degrees C, etc. So what it did is it decided if I do what is is 2 plus 2, it's going through and thinking, I need the getSum function, because we told it that getSum adds two numbers, and we told it get weather, this is what it does. It was able to determine what the arguments were. It's very good at extracting information. It comes back with its answer, the sum of 2 plus 2 is 4. Because we want the answer to come back in a more friendly way, it sends it back, the answer, and what it then does is it comes back with the answer, 2 plus 2 equals 4. So you can see how on the fly you can basically have a lot of different tools that enable you to do different things at runtime. And that's tool calling and or function calling. What about memory? Let's clear the chat. Capital of England. Let's send it. Capital of England. Now I can say, what is its population? And it comes back with the answer. And for some reason my battery is running low. That's it. So you can see now the way it worked is it stored the previous messages. It would have sent back, the capital of England is London. Tell me what its population is. It comes back with a full answer. So here, this is how memory is working, or history, that basically it knows what it refers to. So when you're in ChatGPT and you say, explain more, it knows explain more about the previous answer. And there's only a certain limit that we can send. Because if you're doing lots and lots of questions, the context grows, you're adding tools, it grows and grows. The limit is around 250,000, shall we say, words. It's actually tokens, but token is about 3/4 of a word. Some are 1 million, but basically there's only a certain amount. So that's what comes into context engineering. How can we manage this context? Because it fills up very, very quickly. And of course, it's expensive as well. So this is where the context engineering comes in. So we've seen these examples here. In the repo, we will have explainers for all of these. There's also links to some videos I made about this, links to other articles. But really, this is the idea of HTML agents very quickly. But that's kind of how it's demystified. We've seen straight away how we can almost make our own little chat GPT by asking questions, etc. We've seen how we've had tool calling where it can do more advanced things. One could see how you could build up the one we just did here with tools, etc. Add in the getSum, get the weather, all of these different things. So that's part one in a sense. It's the HTML agent. The main purpose of this is to demystify and simplify it. It's not something mysterious. And to remember the core of all of this, all that's happening time and time again, is this one here. Basically, we're sending a request, we're sending a question and getting an answer. We have to tell it what model. Do we need to supply extra information? And we'll see that when we get into our Kaggle data set and we start doing SQL queries and everything on that. and we just get back an answer. We get and basically then we do something with that. That's all that's happening in all of those HTML pages we saw. Glorified email form or a Slack channel, but behind the scenes it only goes to one place, and we have to supply all the program where it's normally on the server side in traditional coding. We supply our coding in natural language, and we ship those all up, and it bounces back with the answer. So this is coming at part one. Let's have some, if there are any questions before we move, take a break.
Would you mind showing where you inject the knowledge of the tool?
Yeah, sure. So when I come in here, it is HTML explainers, HTML pages, it is the OpenAI RAG. So when we come down, in fact I've called it AI bit. Let's put this here. This is the AI bit. So when we come in here, when we send our messages, what we've actually done up top here is when we do the system prompt, we just add in the extra information. So when we said you're an expert SQL, we actually just add it in, just adding in an extra bit of information into the variable. And that could be massive.
Yeah, but more, sorry, the bit where we inject being able to get the weather or those.
Oh, good. Okay, that's in tool calling. Yep, my mistake. So if we come into tool calling, very good to see. Basically what we do is we give it what we call a list of tools. There's a schema that you say it's a function, what's its name, the description, that's the most important thing because that lets it know, like us, what it actually does, and any parameters. The getSum, so for example, has type A number, B the second number. So that's the tool. And if you notice, what all we're doing is building up what we actually send in the whole context, whether we do it in one go or whether we do it piece by piece. At the end of the day, and you can see why that one snippet is it, once you know what the message is, what the context, the instructions, and the data that you're sending, it's just you get an answer back, let's do something with it. And that gets into like the harness, how do we build an application just around that basic snippet. Good, so I mean that's kind of part one. That's a lot of information. It seems it's the mouse upside down, very difficult thinking, well, how does it actually work? And it feels a bit odd. Totally natural. Okay, that's part one.
Great, so we're going to take everybody in the room.
Sorry, so like when I use ChatGPT quite a lot. So when it says with the API request saying that it's like broken, that's what that is.
That's it.
So that makes
emails down.
sense now.
Emails down. You can't send anything out.
I see. Okay, that makes total sense.
Yeah,
now.
yeah.
Thank
So
you.
like that. Lovely. Good question.
Any more
Okay.
quick questions before the break? Right, well, I mean, for everybody in the room, you can go and grab another drink if you're on YouTube, even grab another drink from home. We'll take a break for a few minutes. I'm going to do my little school teachery bit for a second. The floor outside has just been mopped, so please do not run if you're going to go to the bathroom. We'll be back in a few minutes.
I remember I had some templates for an application. You know, sometimes work just needs to
Hello. I mean, it's a break it down. It's a bit of a shock when you see it. There's nothing. Yeah.
I'm wondering, this tool calling thing, it's part of the skill, is knowing if it needs a tool.
Yeah. Okay, thanks everyone for coming back. So what we're going to do now is we're going to have a look at some examples. One of the things that interested me was, well, how does, say, something like Claude Code work? So in the repo, there's lots of useful articles, some videos. There's a little mini repo that I made. And basically, it turns out that actually, if we have, say, 5 tools, if we can list files, mark down files in our repo, if we can read a file, edit a file, write a file, and use the bash command, that's all we really need. That's kind of all fundamentally things like Claude Code or Codex need. And in fact, just the bash command on its own would work because it can do all the others. So for that, what I'm going to do is basically open up. What I decided to do was make my kind of a version of mini Claude. Let me close all these down. In the repo, I've got this file called miniclaude.py. It basically was an article, and I put the information in and got Claude to make me a mini Claude. But if I kind of run it here, you can see I'm getting a sort of terminal. So what I'm going to do, like we do in most places, we get what they call like the slash commands. We see that in many places. And I'm going to run the slash command hello. And what it does is it produces hello in different colors. Now, how did that happen? What we can do is basically, I've got a folder called slash commands. It doesn't have to be called that. But what I'm doing is I'm actually got lots of my different prompts. So in that prompt, hello, I've got print a colorful ASCII art version of the world, hello, etc. And all I've done is the Python part. Basically, when I do slash, it knows, okay, I've been programmed, whatever comes afterwards, that hello refers to a markdown file in the slash commands folder. So for example, that's how we can do slash hello. And that's when you're using Claude Code, it's just an application that takes in an input and it's designed in such a way that the hello matches the file name. That's just the way it's done. But if you notice, it's still just natural language. It's just a prompt. And at the end of the day, it's one big mechanism to create the right prompt with the right context to send. But it's done in many different ways for efficiency and usefulness. What we could do is also say, write me a hello world Python file. Now, can you see it's calling up some tools as we go through here? It needs to write a file. Let's verify it runs. This is what mini Claude's thinking. It runs the command, Python hello world. It feels done, good, prints out the response, creates the file. So there we can see how it goes through the process of calling tools, checking does it work, etc. But all it's doing is sending everything back, testing it, getting an answer, looping and looping. What we could also do is actually say, hello, in that hello world, update the hello. In fact, what I did is I actually made a little command that if we use the @ symbol, it knows to look up the right file. That was just programming, update hello underscore world.py with colors. Let me first read the content of the file. It's reading the file, it's editing the file, it runs it, it's installing Colorama, runs it, bash command, let's install all these. You can see now how it's working. It's going to and fro. What do I need to do next? Run it. Have I got everything? Going through in a loop, coming all the way back. Well, it's going through quite a lot. In fact, what I'll do is it's doing more. I should have said using the UV. It's done it. So let's just see if it's changed. Hello world. Now you can see the original, we just said print. I should have shown you that. But it's adding all of this stuff here, whereas before, adding all the colors. But you could see how it went through. What do I need to do? I need to install Colorama. I need to check it. Does it run? Have I got the packages? And all it is really, it's like we saw in those HTML pages. It's like a little form that's basically going around. Like we said, what's the capital of England? What's its population? Keeps going around, running tools behind the scenes. So we saw that example. And that's how you can create it. Now, I've got this repo in the links. There's some articles. But behind the scenes, when you're using Claude Code and it's doing all these magical things, it's just a lot more of all of that. It's got tools, it's got history of the messages, it knows what came on before, and little shortcuts, like how you reference a file, or you can click and drag it. So that kind of demystifies a little bit the Claude code, the codex, what goes on behind the scenes. Is that good? So, done that. Let's close that down. Let's go now to our data intelligence agent. Right. So, I'm going to fire it up. Let me just go in here. Go in here. Just check if this is working. Right. So what I did is I upload a Kaggle data set. It's the did not attend Brazilian Kaggle data set, why people don't go for appointments. I loaded it up, and I've done it once, and I'm just using the save data to save time. But the first thing it does is sort of like ETL. It basically goes through ETL. Now what I'm going to do is, how did this app get created? The way that a lot of the modern workflows work is, I first did my ideas, and it was just a little brainstorm of kind of what I wanted done. It doesn't really matter what it was, but it was just a few ideas. I want to create an explanatory report. You'll be interviewed on these questions. Do not do any work. Ask some questions for further clarification. And then I said, create a Kaggle plan of what you would do and store it in the plans folder. So a little idea, a bit like recursive self-improvement, that kind of then embellishes it to something that's more profound. So if I come into plans, and the only reason I've got the underscore so everything's up at the top, so it's neatly done. If I come into the Kaggle plan, it will go through what it's going to do, what things it needs. Just from the data set with no extra information, it's identified the column headers of what city is. It can see all of that. It knows what it needs to look for. Then there's another command that says, having got that, write me a technical specification of how we would actually run it. Don't do it, but just what libraries we're going to use. So that's in the specs. Now, that's doing everything here. And you can see, if you go through in detail, it's kind of the environment, what libraries it needs, etc. Then finally, I have a command called execute. And why don't we actually have a look at these? That if we look at our commands, you can see planner. Read an idea file from the ideas folder, reference data set, what tools can it use, any hints, what model to use, Opus in this case. Ensure the argument is given. It's got through a whole specification of what the plan should involve. And the same when we come to the spec. It's a set of commands and tools that actually say this is what you've got to do, what arguments are required. So all of this is in natural language, and basically it gets created. So it's basically, if you said to a colleague, I've got this rough idea of what I want. Can you kind of create it for me? They'll come back and say, yeah, this is the plan I've got. We can edit that, change things that we need. Then you say, brilliant, can you write now the technical specification for the developers? They'll change it. Then you'll give that to developers. The developers will then create the code. So in this example, when we come down and look at it in the source folder, SRC, CV Analyzer, we can see that we have all of the Fast API code. We're not going to go into that, but that's how I created this app. I just started with a little idea, gave it to Claude to say, create me a plan, create me a spec, run it, and then build it from there. And the app that we actually got was, so I uploaded it, it did the ETL, it kind of knows what rows and columns, what missing cells were in the data set. I also got it to think, what questions would a SQL admin or data analyst like to ask? Don't answer them. What questions would you like to ask? So we send that to the model, and the answer we get back is in SQL. It came back with around 40 different questions you'd probably like to ask. Then we said, create the SQL for that, and also run it. So we now build up some information, some context. And that is stored in this file here, where it's gone through, basically creates the SQL, gets all the data from it, and stores it in a file that will be context that when we want to ask questions, it can refer to that to actually get the answers. Having done all of that, it gives us a report preview and then runs each and every chart that it thinks important. And we can open it up and see it sort of like that if we need to. What I did ask it to do is for every image to create an insight about that. So for example, if we do category no show, that's the chart there. It then made up some business intelligence around it, what it thought. And we can view the insights. This is just application where it's going through each of the different things, either just the reports. And we'll come back and then we'll ask questions about what's going on, but just wanted to show what it is. The other thing, and this was actually a Data Cove tutorial or a video on YouTube that said, don't just analyze your data, ask sort of questions to get meaning from it. So I thought, well, what we'll do is let's put, what are the objectives? How can we reduce did not attend occurrences? That's what we really want to answer. We don't want to just analyze the data. So what I then did is ask it to build that actual thing, generate the response, and if we open up, it can produce a report of how can we reduce did not attend occurrences, the evidence, its report. Again, all we're doing is we're taking a question, it's got access to all that information, it can formulate an answer. It's using the context that we provide it. I also then asked as well, ask AI, ask a question, so that if, say, a manager wants to ask a question in natural language, they can do it. It's using a different model, it's thinking away, it'll come back as we go through. I'll go to the next section. But one of the most important things is how do we verify things are actually working well? So what we can do is I asked it to create an adversarial reviewer that basically acts as an independent judge of what's going on. And it came up, right, here's the answer from the AI. It comes back with the answers, but it also references the SQL sources. And I said to it, only use the SQL answers and the images. Don't kind of make up anything on your own. So here it used, these were all the references it needed for that. And it has its answer here. So the adversarial reviewer, basically, it came up with what it needed to do. I just said, create an adversarial reviewer with a different model. It formulated that this is what would be useful. And as you can see, it's using a different model and basically gives an overall verdict, strength, weaknesses, etc. Now, if you were to look at this, you could sort of see it's kind of a complex thing, but all that's happening is we're sending different questions and answers with the right information and we're getting a response. The application itself is what's the harness? How do we handle all these different things? So this is, for example, a data set. There's a link to the repo so you can build it yourself. I use Open Router, which directs it to different models. You just have one endpoint because Anthropic has a different signature to OpenAI, so it makes it a lot easier, and you can use some freer models, some cheaper models. But that's how I've been able to use different models for different things. But the interesting thing is having what we call a so-called verifier agent. That actually something that challenges and maybe refines it and brings back a new answer, a critique. Then you get a final review. A bit like in organisations, you get somebody that does one report, somebody that does another. You get the overall editor that takes it all, merges it together and says, right, this is the final version. But again, as complex as this might seem, it's question and answer, sending to a model, send the right question, the right information, you'll hopefully get the right answer. So if we have a quick look at the repo, what I'd like just to show is in .claude, again, we've got all these commands that I use. For example, in the insights command, I gave it in a certain, it created the commands. I said, write a command to do this. It creates all of this. I didn't write any of this code. Everything was created except for that initial plan. The SQL titles, here is examine the CSV and generate a categorized list of useful SQL queries in natural language, what tools to use, where is the file. It created, this is all the things it would need to do, all the information that was important so that it can do that. So I could just do /SQL title and it would actually do it for me on the command line, but it's been built into the app. So what you can really see is this whole application is just clear thinking, clear descriptions, and picking the right models. It's actually very much like the business analyst or the product manager that basically knows what we want, asks the right questions, the model will bring back the answer. So having gone through that, there are many other things you could do, but this is an example of a Kaggle data set. And my proof of the pudding is an old school buddy is an oncologist. He heads research in oncology, and he works with genetics data sets. He gave me one with no information. It's about 5,000 columns wide. I mean, it's very long. The columns just had like A1, A2, etc. I just said, here's a CSV of oncology. Do ETL, do plot all the charts, and ask me some useful questions. Just ran it. He looked at it. He could zone in on one particular gene because he knows that kind of thing well. And he said, yeah, that's accurate. He could see the chart, that's accurate, and was impressed with the questions it asked back because it asked, oh, I didn't think about that. So that was my proof of the pudding of does this actually work? If you play around with this and on your own CSV, you're thinking, yeah, it's good, it's not good. Depends on the model. You can use some models cheaper, but in the repo, when you have a look at the agent, you can change it as you wish. So we've really gone now as complex as that. If we remember that come back, remember, it was this. I said at the beginning, this is the most important takeaway. We send an email, we tell it the model, we tell it kind of who the character is, a set of system messages, a set of user messages, which will change each time. We might sort of say, well, number of tokens, the degree of creativity. Normally temperature set to 0. You want no creativity. You want it as deterministic as possible. 0 is not deterministic, and there's an article in the repo to explain all of that, because there's lots of different answers on the internet, as is the case. But this here, this snippet code, is what an AI agent is. It's a question and answer. We need prompting, good question, we need good context, we need memory of what went on before, we need looping, and the response we get back, we then handle with the harness to say, what do we do next? So I'll open it up now to thoughts and comments and questions. Hello.
Sorry.
One second.
Sorry.
And just to remind you, it is mind-boggling, all of this, because it's something so different to the way we've worked through our lives of knowing exactly and planning everything. So if you're looking and you're thinking, I get it, but I don't, perfectly natural, it's a matter of changing the circuits in the brain to kind of get into this agentic framework. Hello?
So I think there's two major questions here. Number one is model selection. I assume you're just letting Cord select appropriate models for doing the different steps in the task.
In this particular case, I actually assigned it. You can do it, and in fact, if you use Open Router, it can pick the best model for me on auto if you want. But here, I think when I did the ask, I said pick a good model, Opus. The others could just be a lower level model. So those can be predefined, but they could be probabilistically defined, because it's just a variable, yeah.
And my other question has gone. We're considering writing the markdown now as writing code. You sort of refer to it as code, and so we're not writing lines of Python or lines of R, or it's all dead and buried. We just write markdown.
Well, yeah, I mean, it's natural. Jensen Huang, he said, the new programming language is natural language. Now, years ago, when they used to do machine code, the ones and the zeros, when the C language came in, they called that natural language programming. Because for them, it was kind of words. And so at what level, when we use Python, well, we don't compile it ourselves. We let the compiler translate it into machine code. So at what level? And all that's happened is the abstraction's gone up one more level that transpiles it into Python, which then gets into Python C, yada, yada, yada.
But there's a level of sort of almost attributes to the titles to the sections in the markdowns. There's some distinct...
Yes, and making things bold. And there's a new kind of topic coming up that maybe HTML is better because it's far more structured and has more options and sliders as opposed to Markdown. That's an evolving topic that actually maybe that's more useful context since models can sort of see images, etc. But and as I say, everything I've done today, everything in that repo, all created, I say, create me the README. And it creates the big README. Giving them an article on how to run it for people who want to use it. Claude Code.
Any more questions for Craig? Steve.
I've just got, I know you said that it's sort of concerning in general and it's kind of mind-blowing, but With the SQL statements, is the tool element, is there a tool for running the SQL statement?
What it can do, actually, because if you've got a SQL statement, it can run it in like a system command in Bash. It can actually run it. It can run it.
Yeah.
In fact, I think what it does is actually import it in pandas and use pandas to run the SQL. So it can import a library. So that's what it does. And so when it sees it's an SQL, it says, oh, I've got an SQL. The tool, what tool do I need? I need the pandas library tool. So then it's got pandas installed in it. I think we may have seen it in the trace. So it runs it against panda, runs it the command line, brings back the answer. So it doesn't actually do the SQL. It uses the pandas.
So I just wonder if it's sort of looping like that, if it's writing its own SQL and then verifying its own results. It's like encouraging, having a tool that you can verify is quite good, like what's the weather.
Yeah.
But if it's writing the instructions for its own results, it's quite difficult, isn't it? Someone's got to verify.
Yeah.
I know the adversarial thing maybe, but you've got to like go...
That's it. I mean,
That
but
is
at the
what
end
we're
of the day, I mean, yes, you could say, let's make an SQL verifier that runs it. But at the end of the day, how do you know the SQL verifier is right? So at the end of the day, you've got to have a human somewhere that tests something to say, yeah, this actually works. Because otherwise you're relying on something that hasn't been tested to be a tester.
Yeah.
I mean, I have one question maybe that I'd like to ask is, when you came in at the start about AI agents, and now, what's the difference? Does anyone, what's been the difference having seen what kind of misconceptions or myths maybe been blown? Any thoughts? Is it all hocus pocus? Is it magic? Just kind of what's your kind of impression, having gone through the talk? I know it's kind of a lot to take in.
And if you have thoughts, please put your hand in the air so I can bring you the microphone as well. Keith? Is there anyone else? I will let Keith go. Keith likes a chat. Go on, Keith.
So this is about where I've just about got to with my model. So this is quite nice reinforcement of, it is actually quite simple, which you find with a lot of IT things. It's simple. It's just got a cool new marketing veneer on the top.
Yes, it's still software engineering, the whole process of folding. It's not the vibe coding, the one shot, build me everything. So yes, that is.
Are you finding now though that, so the bits I've started using AI for, you then end up with a whole load of great big readmes that look amazing, but then you're reading material, and I've just been working on something collaborative with somebody else as well, where they're generating a lot of the stuff using AI, but now I'm reviewing their work, but reading loads of very AI feeling stuff because they've used AI to make it. And I don't know, it makes it annoying to have to read lots of stuff, and now I'm giving that to AI to summarize.
Exactly. I think they say about 100 lines is what you can cope with. And as you say, people suddenly do PRs, pull requests at GitHub, and they've generated, and some poor person has to kind of look at it and work through this big kind of view, whereas before in the old days it was quite sort of small. So yeah, and then in the end it's agent coding, agent reviewing, the humans. I think I saw there was a meme of just like a keyboard with like do it again. That was all that was on the keyboard type thing. It's just kind of like, yeah, solve this. We're just copying and pasting the error. So yeah, but there is software engineering behind the scenes. How do we make a good app that's robust for production?
Any more?
Can you perhaps talk about the cost of running this?
Yeah, well, I mean, I think sort of price is per million tokens, about 1 million words, tends to be $3, $4. I mean, some are more, some are less. And then that's the input, and on the output, it's usually 2 or 3 times that. So, yeah, it really depends how much you're doing and how much you're sending. If you're sending the whole book of code of something like that, 300 pages every time, you're going to be eating it up. But to be honest, I mean, when I was using like the £20 a month subscription, it did quite a lot for me. You know, you get windows of sessions of 5 hours at a sort of time. So, and actually the cost of inference from when it first started with ChatGPT to now, and it's the cost of intelligence in a sense that although you're getting how much intelligence you get for, it's gone down by 99.7%. That's how much it's dropped over the last 3 years. So actually what you get for your dollar is kind of been reduced by 99%. It's getting cheaper and cheaper. There are a lot more, when you go to Open Router, cheaper models. So with a lot of models, like the Opus for Claude is the kind of most advanced, but you don't need that. You can get away with much smaller models to do kind of like making the SQL statements. What I use in the Ask AI is something more complex. It's got to think and reason far more. So, yeah. And there's some in fact, Jensen Huang said that if one of his engineers who was, say, on $500,000 a year, if he hadn't spent £250,000 on tokens, he would think he's a bad engineer. And now I think when people go for jobs, they ask, what's my token limit? How much can I spend? Because that's the most important thing. So, yeah, that's a sort of change. But companies spend fortunes, but it pays. Because one last thing before I close, we saw how we did the data intelligence agent. That was just one session. I can open up 10, 15, 20 sessions to work on 10, 15 different files. And what they do, like at Anthropic, the creator, he kind of like goes in, sets up a task, sets up like 12 spinning plates, goes for coffee, comes back, sort of spins them again and works round. For me, 10 to 100 times what a person would do normally is sort of the norm for something like this, simply because A, it's very fast, but B, you can be doing 10, 20 tasks in parallel. You can have several computers.
Great. Going to have one last comment over here.
Hi there. So I get the concept of an agent, and you sort of the looping and the tool calling, etc. And then you've got a harness, which I guess they're very similar in that respect. But would you class a harness as almost the grouping of multiple agents?
Exactly. The harness is the program application, a bit like when if you've ever done normal programming, you've kind of got lots of classes. It's the big orchestrator. So yes, in a sense, the harness is how do you handle all these. Let's take the example of deep research. You've got a topic. One agent will split it up into 12 different topics. Another agent will go to the internet, get all the information. Another one will combine it all together. But you can run them in sort of like separate sessions. So what was the question again?
So there was just the distinguishing between those two, between a harness and an agent, which I think you've clarified there. Then what about sort of the fairly newer sort of process of dealing with sub-agents, that sort of spin-off? So that is, I guess, the point of what the harness does. But have you worked with sort of dealing with those programmatically as well, where you deal with, spinning off 10 sub-agents to all pull back together for an orchestrator to...
Again, yes, good question. Again, they're just functions. So it's like if you're just running off different functions. A sub-agent is still a prompt. It's just a mini version. So you've got lots of those little loops all going on. Lots of those, a sub-agent is like a spinning plate. An agent might be doing 10 plates. Then you might have the orchestrator that's managing 10 agents, each holding 10 plates. So in a sense, a sub-agent, it's just terminology. It's still at the end, again, the basic question-answer. And so is an agent. It's question-answer. It's all question and answer. It's kind of the names we give it to give it a design pattern.
Okay.
Yeah, thanks.
Great.
Lovely. Well, thank you very much, everyone. It's a lot to take in. Plenty of information in the repo if you want to work away with links. Thank you very much.
Yeah, and while Craig's packing up, and I've got to set up again, because you've got to listen to me talk again, only for a few minutes, don't worry, and then I'll let you go to the pub. But just, again, a massive thank you to Craig. I think whenever I think of AI agents and people that I know that know a lot about AI agents, Craig is always the first person that comes to mind. Very knowledgeable, so really happy that Craig's come to share his knowledge with our wonderful community this evening. If you can all bear with me, maybe talk amongst yourselves for a moment while we sort out the tech here. I'm going to just plug in and show you a few more slides.
I don't know if I've kind of taken one plug out too many.
That's fine, don't worry.
Oh, that's yours?
Yeah, I just need to get to whack my You can feel happy to work in the background.
We had all these little fights, we have and I'm looking
at Craig's unplugged wires. Oh, I'm not plugged in. Because all sorts of wires are unplugging.
Oh, dear.
Do we don't want that one? Let me just do this. Hang on. There we go. Right, people of Brighton, who wants to go to the pub? If you want to go to the pub, be quiet. If you don't want to go to the pub, keep talking, and the event can last forever. If you wish to go to the pub, I shall close this event in the next few minutes. Just a few announcements to end, though. We are running a free SQL introductory workshop at Data Cove. That is on Thursday, the 4th of June. Yes, I've got the date. I thought that date was in my head as the date it was, but I had to double check. Thursday, the 4th of June, 2 p.m. It is completely free online. Let's hope Laura's got her voice back by then. Otherwise, it'll be a very interesting introduction to SQL workshop, because it'll be a very silent one. You can sign up for free. There'll be all of the details on our Linktree page at the end, or if you scan any of the QR codes on the Data Code banners around this evening, you'll be able to find out more about that. As well as SQL, we also train in various other technologies, so R and Python, of course, Shiny, which brings all of them together, Power BI, Looker Studio, lots and lots of other things, but also non-technical training. So if your teams want to be empowered and understand how to tell wonderful stories from data. As you can tell at Data Cove, we love telling stories and standing up and talking for as long as we can. So if that's something that you're interested in for yourself or your teams, come and have a chat with me before you go this evening, or even in the pub afterwards. The level of intelligence that you get from me in the pub may be slightly lower as the evening goes on, though, but we will try. Do save the date and do come back and join us for future Brighton Data Intelligence Network events. These are the events for the rest of the year. They are all going to be in this room, this wonderful building at Platform 9, where now you have Silicon Brighton, Eagle Labs and Data Cove all in the same place. So if any of you do want to come and work in here, come and chat to any of us and we can tell you more about that too. I'm just going to leave this by saying thank you very much. We are off to the Dorset. If you don't know where the Dorset is, shame on you! It's the best pub. No, Dorset is one of my favourite pubs here. If you go out of the building, down the stairs, turn right, it's a couple of minutes down the road. I'm sure there'll be somebody leading the pack and the party. Normally it's me. Unfortunately, I have to stay and pack up. Otherwise, I might not be a member here for very much longer if I leave it in a mess, get kicked out. A couple of other just little bits. This QR code here, as many of the Data Cove QR codes have two. Keith has pointed something out. Have we got a...
No, the building we're in is in the corner of the picture.
Oh, there you go. That's brilliant. I thought it was pointing out the spelling mistake on the slide. Or Cameron's finally got his face there. This wonderful QR code, that will take you to our Linktree. It's got all of our socials. So this was streamed live tonight on YouTube. If you want to see other meetups and other intelligence from us, because we're a very data intelligent bunch, please follow us on YouTube, any of the other socials you see there. It's got links to all of our meetup groups. It's got links to Earl, which is really important. Make sure you're at Earl. Hopefully I've empowered everybody to get their boss to make them pay for tickets in the morning. And importantly, if you really enjoyed this evening and think that the Data Intelligence Network is the best thing on earth, please leave us a Google review as well, because it really helps us. And there's a link to that through the Linktree as well. I'm going to stay and pack up. Thank you everybody for coming. Thank you if you've been watching online on YouTube as well. We will see you again in July, or indeed at the Dorset in a few minutes. Thank you very much.